Hi everyone, welcome to our demo presentation. My name is Dominic Saylor and I'll be talking about our system darkjargon.net, a platform for understanding underground conversation with latent meaning. This is joint work with Wei Liu, Yunan Zhang, Xiaofeng Wang, and Zhengxiang Zhai. I want to start by giving a little background and discuss dark jargon. Dark jargon is an essential part of underground conversation, which are benign looking words that have hidden or latent, sometimes sinister meanings. And these are frequently used by participants in underground forums to hide their illicit activities. Some examples here are the word rat, which is actually an acronym for Remote Access Trojan, the word popcorn, which is sometimes used to refer to a special type of marijuana, and ecstasy, which is used to refer to MDMA, which is a hallucinogenic drug. Identifying these dark jargon words and the meaning of these dark jargon words is essential for understanding the cybercrime that is facilitated through social media platforms. And in this domain, or in this context, in order to cater to the needs of researchers or law enforcement agents and also white hat hackers, we want to give them a system that enables them to make sense of underground conversation and collaboratively discover dark jargon words. I want to start by introducing the problem setup. And here we follow the general framework that was proposed by us in a previous work, where we use words with no hidden meaning, which we call clean words, as direct explanation of dark jargon words, which we call dark words. And the concrete instantiation of that general framework is that given a dark corpus, C sub dark, and a clean corpus, C sub clean, we want to build a joint vocabulary. And then for each dark word in our dark corpus, we want to find a clean word or a probability distribution over clean words that express the hidden meaning of the dark word. And in this work, we propose two methodologies to achieve this mapping. The first methodology is based on our previous work, which is doing the interpretation of dark words using word context distributions. And the second novel method is doing the interpretation using masked language modeling. The intuition here is that a dark word, for example, rat, will appear in different contexts than the clean word rat would appear in. So we would expect the context to be more similar to the clean word malware as it would be to the clean word mouse. And here we build basically a word context distribution for each word in our vocabulary using a sliding window approach. And then we build context distribution separately for the dark and clean corpora, and then estimate two probability distributions, which we can think of kind of like a conditional probability, where the probability of a dark word is estimated on the dark corpus, the probability of a clean word is estimated on the clean corpus. And then in order to get the dissimilarity of two words, we use KL divergence, which is basically the difference between probability distributions of a clean and a dark word, given their corpora. The novel method that we introduce here is the interpretation using masked language modeling. And the goal of masked language modeling is to predict a hidden or which is called masked token in an input sequence. Specifically, this prediction leverages the context that a token appears in. And using a pre-trained model, like for example, the BERT model, the prediction of that missing token will most likely be the clean word when a dark word is masked in our sequence. And we then aggregate over all sequences in the dark corpus where a specific target dark word appears in order to get our scoring metric. With this slide, I would like to give a little more detail about the masked language modeling method. So here we can see that we start by showing an unmodified tokenized sentence that our target dark word appears in. And in this case, the dark word is rat. We then replace the dark word with the masked token and use BERT to predict this token given the context of the input sequence. So for each word in our vocabulary, BERT then gives us a probability of it replacing the masked token. And from this probability, we derive a ranking that we use to arrive at our score for a target word and the dark word W sub D. I would now like to move on to demonstrate our system that is available at darkjargon.net. So we observed the following communication trace in the Darkcode forum, where a user basically asks, need zero-day USB exploit, how to get help and help. And then a user second answers zero-day USB exploit and so on. And let's say I would want to find out what the word zero-day actually means. For this, I can go to the darkjargon.net homepage, and here I will find a list of different dark terms on the left, their definition, and also the definition source. So we can see here already, dark term is the first entry, which is a zero-day vulnerability is a computer software vulnerability that is unknown to those who should be interested in mitigating the vulnerability, including the vendor of the target software. If this is not enough information for us, we can go to the definition source, where we basically do find more information about zero-day vulnerability and the definition, besides the definition. Going back to this page, we can then get more information about a certain dark term by clicking on it, which then opens the exploration interface. We're here on the top. You can see the currently selected dark term. And the very first plot here, we can see the usage over time, which basically shows you the different usage statistics overall in all major forums. We can then also look into specific forums, so we can see that there's a lot less usage in the hack forums forum. Also, the Darkcode forum has most of the usage, as we can see. When we then further scroll down, we can see the clean term mappings for the selected dark term, and we have different mapping methods. So, for example, using the KL divergence methodology, we see that the most likely words in the Darkcode forum would be already intercept, applet, virus total. In the hack forums, actually zero-day itself is used as an explanation. GTAG, tapeholds. So these are maybe not very informative. So we can also look at the birth model predictions by just selecting this and clicking update. And here we see words like security, software, attack, vulnerability, program, security again, information. So these seem to be more related to what we're looking for and give us a better explanation of the zero-day vulnerability. So switching between these two mapping methods, we get the flexibility of looking into different interpretations of the same word. When we click on the collaborative button, we can basically see a list of already contributed dark terms, and this is to facilitate basically the common exploration or the collaborative exploration of dark term words. So we can see, for example, that Coke and Molly are already identified words, and we can look at a definition and say, okay, these are, I agree with the statement, and I can basically give some positive or negative feedback on already explored dark terms. If I want to add my own term or a newly developed term, let's say the word shrooms, we can click here on the add dark term button and then provide the according information. So here I basically look into the text from Wikipedia that I can just paste here. And then I also want to say where I found this definition. And I can then give also a name to the database entry. I can then click submit, and we'll see that my entry will appear here in the list. So other researchers can take a look at it and evaluate it. The final part is the download interface, where here we can basically look at all the data sets that are used. For example, the verified dark terms from the homepage or the user dark terms. And when we click on the download link here, we receive a CSV file with the most up-to-date version, where we can see here that the entry we just added is already part of the data set. With this, I would like to thank you so much for your attention. If you'd like to find out more about my research, please visit me at dominiksaylor.com. and I'm looking forward to seeing you at this year's SIGIR.